Hello guys, what's going on? And today we'll be going over the AMC 10B 2024 problems 22 and 24. Okay, so problem 22. So a group of 16 people will be partitioned into four indistinguishable four-person committees. Each committee will have one chairperson and one secretary. The number of different ways to make these assignments can be written as 3 to the power of r times m, or r and m are positive integers, and m is not divisible by 3. What is r? Okay, so firstly, we're asked to find r, and so essentially what r is if we call the number of ways to like form the committee and select the chairperson and secretary n, we can set that n is equal to, it can be written as 3 to the r to the power of m, and we're asked just to find what is r. And since m has no multiples to 3, it would have a 3 to the 0 in its prime factorization. So we're asked to find just how many multiples of 3 we have in there. Okay, so now we know we're trying to find the number of 3's in this way. So now how do we really calculate how many ways can we split 16 people into four indistinguishable four-person committees? Okay, so if we take it, four indistinguishable four-person committees. So if we take it one committee at a time, let's just consider what happened. So how many ways can you pick four-person for the first committee? So there's 16 total people, and we're choosing 4 people because order doesn't matter. How many ways can you choose the next people? So the next would be 16 minus 4, there would be 12 people left, and from them we're choosing committee of 4. And then for the next time, we're picking, there are 8 people left, and we're picking any of the 4 people left. So I choose 4, and finally we have 4 people left, and we're choosing any of these 4 to make up the 4th committee. Alright, so this is the amount of ways to make the four-person committees, but realizing that they have indistinguishable, meaning if they had a committee of like 1, 2, 3, 4, let's just name the people 1, 2, 3, 4, and then 5, 6, 7, 8, and then 9, 10, and then 12, 13, 14, 15, 16, 17, 18. Like if we split them up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, 14, we realize that we can like reorder these. So even if at the start we chose 5, 6, 7, 8, 1, 2, 3, 4, and then 9, 10, 11, 12, 13, 14, 15, 16, these would still be the same arrangement. So we have to divide a count, because we're over counting each of the four-person committees by the amount of ways to arrange them from the four things. So since there are 4 committees, there would be 4 factorial ways because committees are indistinguishable. So we have to divide this by 4 factorial. So this is just how many ways we can make the 4-person committees. So if we simplify this, we realize that 16 factorial over 4 factorial is, or over 16 choose 4, 16 factorial over 4 minus 16 factorial is 12 factorial, 4 times 4 factorial times 12 factorial over 4 minus 12, 8 factorial times 4 factorial, and then times 8 factorial over 4 factorial, 8 minus 4 is 4 factorial over 4 factorial, and then times 4 factorial over 0 factorial over 4 factorial. And also 0 factorial is 1, if you weren't aware. We also realized that we can like cancel out like this. Cancel these out, cancel these out, cancel these out. So we're left with 16 factorial in the top, and 1, 2, 3, 4 factorials in the bottom. So then that's just the top, so we can rewrite the top as 16 factorial over 4 factorial to the 4th, all over the bottom, which is 4 factorial. And simplifying this, if we multiply both sides of the fraction, like this side and the bottom side, by 4 factorial to the 4th, we would get 16 factorial over 4 factorial to the 5th. Okay. Okay, so I'm just going to rewrite this down. So we had 16 factorial over 4 factorial to the 5th amount of ways to form the 4 indistinguishable 4-person committees. And now we're also asked that once we find these committees, we need to assign 1 chairperson and 1 secretary for each of them. So how many ways could we do that? So let's say we have 4 people, A, B, C, and D. So for the chairperson, it can be any 4 of them, like A, B, C, or just say it's B. So we have 4 options for the chair. And then secretary, it can be any of the other 3 because we got rid of B, so it can be A, C, or D. So we'll just say it's C, and we have 3 options for these. And because chairperson and secretary are different, the order does matter. So for each of them, we would have 4 times 3 ways to choose these people. And then now also remember, we could write this as times 12 to the power 4 because we need to choose 1 chairperson and 1 secretary for all 4 groups. But realizing that we're only trying to find the power of 3, we can just write this out as times 3 times 4 to the power of 4. So we know that there will be 4 3s from this. Okay, so now this is the amount of ways that we can find 16 people into 4 indistinguishable. Like this is the amount of ways we put the conditions, and now we're just asked to find the power of 3. So okay, firstly let's find this. This is easy. This gives us 4 3s, 1 for each power. Okay, now how do we find these? So 16 factorial. 16 factorial. How many 3s would it have? So it would have 3, 6, 9, all the way up to 15. So that's 5 3s. And then how many 9s would it have? Like 3 squared. So 9, there would only be 1 9, not 18. So we add another 1 because we only counted the first 3 multiple of 9. Like 3 is 9, but we didn't count as 3 squared. So we add 1. And then how many 27s? There were clearly 0 27s. It's clearly only 6 powers of 3. So this would give us 6, right? 6. So we have 6 powers of 3 in the top plus 4 powers. And because when you multiply exponents, it's like you add the power. So that this would have 6, this would have 4. The total would be 6 plus 4. And then now how many are we dividing by? So 4 factorial clearly 1 times 2 times 3 times 4. It contains 1 3. So each of them would have 1 3 and there would be 5. So we're dividing by 3 to the 5th. And because when you divide by like with the power of 5, you have to subtract 5 from the exponent. So there we would be getting rid of 3 to the power of 5s. Okay, so minus 5. That would lead to minus 5. So you would just add these all up. 6 plus 4 minus 5. And you would get that there are 5 total multiples of 3 in this problem. So essentially the key idea was first you have to understand how many ways you can pick the indistinguishable groups. So each of them was like 16 choose 4, 12 choose 4, 8 choose 4, and then we have to also realize that you have to divide by 4 factorial because they're indistinguishable, so the order of the groups doesn't matter. And then you just have to multiply by 3 times 4 for each group because that's how many ways we can pick 1 chairperson and 1 secretary. Finally, we realized that we're just trying to find the power of 3, so we just calculate how many 3s we get from this expression, add those 2, and subtract how many 3s we get from this expression. And we get 5. Okay. Now, going on to the problem 24, we're asked, let P of m equals m over 2 plus m squared over 4 plus m to the 4th over 8 plus m to the 8th over 8. How many values of P of 2022, P of 2023, P of 2024, and P of 2025 are integers? Okay, so all these means is when we plug in 2022, 2023, 2024, and 2025 as m, this should result as an integer. So that's all we're trying to find. So thinking about this, we like just off the m to the 8, clearly we cannot bash this out because 2022 to the power of 8 is way too high. So what we can consider here is just for this to be an integer, we realize that we can find these moduli too. Like, so if a number was congruent to 0 mod 2, all it means if a number was like n is congruent to 0 mod 2, all that means is that it has a remainder of 0 when divisible by 2. So if we realize that a number is divisible by 2, divisible by 4, divisible by 8, or divisible, then we realize that it's going to be an integer. So that's just taking mod. So let's just consider each of these integers mod 2, 4, and 8 separately, so we can find what m would be, m squared would be m fourth, and m to the 8th over their respective mods. So 2022. So 2022 would be congruent to, this is divisible by 2, so it can be 0 mod 2. Mod 4, you would get 4 times 500 is 2000, and 4 times 5 is 20, so you'd have 2 remainder. 2 mod 4, and then 8. 8 times 200 is 1600. 1600 minus this is 422. 8 times 50 is 400. 422 minus 400 is 22, and then 22 minus 2 times 8 is 6. So this would be 6 mod 8. Okay, so we have these values. Okay, so we know like when m is converted to 0 mod 2, so what does that mean? We realize that if n is converted to 0 mod any m, it just loses a remainder of 0. So it has to be an integer. So if we just plug this in, m over 2 for 2022, it would leave a remainder of, because this is 0, right? So it would leave a remainder of an integer. So let's just replace it with 0. So 0 over 2, get rid of that. And then it would leave a remainder of 2 moduli 4. So what would it be squared? So just 2 squared is 4. 4 over 4 is 1. That's an integer. Cancel that out. And it'll leave a remainder of 6 modulus 8. So what would the remainder be when you plug in 6 to the 4th over 8? Also, we can realize that this would be divisible because 6 is 2 times 3. So this would clearly have more than 3 factors of 2 would have 4. And then when we divide by 8, 8 only has 3 factors, so it would be divisible. And clearly m to the 8th is just 6 to the 4th times is a multiple of this, so it would also be an integer. So all 4 of these would be integers for 2022. So 2022 would be an integer. We can check that. Okay, now if we consider 2023, if we move just 1 up, all of these mods would shift 1 up because the remainder would go 1 up. Like let's say n was congruent to a mod p. If we just have n plus 1, we just have to, it would just be congruent to a plus 1 mod p, simply because we're just adding 1 to the number, so we just have to add 1 to the remainder also. And if it becomes like over 8, like if the remainder, like if the remainder was 7 and then became 8, then we can just subtract an 8 when we have 0. So 2023 would become 1 mod 2. Clearly it's odd, so it'd be congruent to 1. And then it would be congruent to 3 mod 4. And then it would be congruent to 7 mod 8. Okay, so here, sorry, I have to clear this. Sorry. We know that this works. So 1 mod 2, 3 mod 4, and then 7. Okay, so we plug in 1, we'll get 1/2 from here. M squared, 3 squared is 9. 9 fourth. We realize because they're congruent, we can just plug them in because all of the integers below it, like 2 and 2025 is congruent to, okay, you can just plug in because they're congruent. Okay, and then m to the 4th is 7. So also we know that 7 is congruent to -1 mod 8 because you can just subtract a certain amount of 8s, mod 8. So this would be congruent to -1 to the 4th is just 1. So 1/8, and then 1/8 1 to the 1 squared would be, because like m to the 4th squared would be 1, and then over 8. So from here you would get 1/8 plus 1/8 is 1/4. 1/4 plus 9/4 is 10/4. So your remainder with 1/2 plus 10/4. So 1/2 is 2/4. 2/4 plus 10/4 is 12/4, and 12/4 is 3. So that's clearly an integer as well. Okay, now we're left with 2024. So if we add one to each remainder, we would get 0 because we get to 2 and we loop over, we subtract 2. And then 3 plus 1 is 4. Subtract 4 because it's 4. Congruent to 0 mod 4, and then this would be congruent to 0 mod 8. Okay, so realizing that these are all congruent to 0, if you just plug in 0, have 0 over 2 plus 0 over 4 plus 0 over 8 plus 0 over 8, this would just be 0, and that would be an integer. So this would also be an integer. And now if we get 2025, we just have to add one more, so it would just be 1 mod all of them. So all we're left with is plugging in 1 for each of these, because we would add one remainder, so 1 mod 2, 1 mod 4, 1 mod 8. So let me just write that out. So if we just plug those in, we get 1/2 plus 1/4 plus 1/8 plus 1/8. 1/8 plus 1/8 is 1/4. 1/4 plus 1/4 is 1/2, and 1/2 plus 1/2 is 1. It's 1, and 1 is an integer. Also integer. All 4 of these integers, so the answer would be 4. Essentially, all we need to know for this one is just consider mods, because you just have to see it divisible by this and realize that these numbers are congruent to certain residues, mod 2, 4, and 8, and then once we plug in their residues, if they leave an integer value, so should plug in their respective numbers. And then from there we got 4. Thank you for watching. Hope you learned something, and hope you have a great day.